Hello everybody, Namaskar. Now in this 17th lecture of the course, we will study about sorting and grading practices and protocols for the horticultural produces. The topics or concept that is covered in this lecture include sorting and criteria for sorting, then sizing of fruits and vegetables, grading and the grading systems, various systems which are used for grading of the produces, and toward the end we will also discuss some of the new innovations, new development in the grading system of fruits, vegetables, spices, etc. So, let us see first what does sorting means. So, sorting refers to the separation of foods into categories, various categories based on a measurable physical properties. That is, materials can be sorted on the basis of size, on the basis of shape, weight, color and so on. Okay. As you can see here in the picture, that is, these are all the apples and the different colors you can say. So, all these apples having the same color can be made into one group, they can be sorted into one group, etc. and so on. So, the purpose of sorting is to remove items which are of undersize, oversize or underripe, or if there are any mishappen and damaged commodities there, that can be removed. To meet the requirement of a grade established by center, state or marketing agreement authorities or other regulatory agencies of the country. Okay. So, to meet their requirement, the sorting is done sometimes. Also, sorting is done to improve attractiveness of the produce and to reduce the quantity to be handled during subsequent operations like grading, packing, etc. It is also done to remove the damaged produce, which reduces losses due to post harvest diseases during transport and storage. As you have seen in the last slide, the various criteria of the sorting may be size, weight, other physical property. So, we will see one by one. So, first the sorting on the basis of the weight, that is, it is the most precise method of sorting and independent of the shape of the product. Okay. Fruits or vegetables like apple may be separated into weight categories using spring loaded strain gauge or electronic weighing devices installed with the conveyor system or conveying system. In some places, a high pressure or compressed air is utilized to blow lesser weights and it separates heavier products. A disadvantage of the weight sorting is the relatively long time required per unit. This method is more appropriate for the smaller produce. Larger weight materials cannot be sorted using this to the accuracy. Then size sorting on the basis of the size, like size sorting is less precise than the weight sorting, but it is considerably cheaper. Size categories could include a number of physical parameters including as volume, access, perimeter measurement, calculation of projected area, etc. Sorting into size categories requires some sort of screen. That is, screens, they may be a fixed aperture or variable aperture. Fixed aperture screens have number of screens in series or in parallel to sort produce into several categories simultaneously, whereas the variable aperture screens, they have either a continuous or stepwise diverging apparatus. These are much gentler and are commonly used with large or more delicate fruits. You can see here some of the size sorting equipment are shown in the figure. That is one with the concentric drum screen is here. The material, the fruits or vegetable is fed into the central screen, it moves, there are various holes all right, of different sizes. So, accordingly when it moves, then it is like some smaller size is come here this, then medium size, large size, it is grouped made of different smaller, medium, large, etc. Then the roller size sorter, here that is the, you see these are the two rollers and there is a widening gap between the rollers, etc. Okay. So, the material is moving from here, the gap here at one end of the roller is smaller, and when it moves the gap increases. So, accordingly it separates various sizes. Also there is a belt and roller sorter. So, see in the belt, that is the roller, it moves, so that sloping conveyor belt is used, and it is the direction of the movement is shown by the arrow. So, as it goes down, it in the different sizes, etc. Again the materials are grouped. You are getting the material of different size. According to size, these are the separated one. Then shape is another criteria used to sort fruits or vegetable. It is useful in cases where the produce is likely to be of uneven sizes and weight. It is particularly applicable to spice seed, which may contain other seeds. The principle is that discs or cylinders with accurately shaped indentants will pick up the spice seed or fruits of the correct shape when rotated through the stalk, while other shapes will remain in the feed. Density is another criteria. The suitability of some produces depends on the sorting by density. Some properties of the produce can be defined by its density. For example, density of pea correlates well with the tenderness and sweetness. Total solids content of potatoes determines its suitability for manufacture of crisp and dried products. So, accordingly the processable varieties of commodity are the varieties which are not suitable for processing. They can also be sorted on the basis of one or two, like for example density. So, sorting on the basis of density can be achieved using a flotation in the brine at different concentration, or there are other criteria as well. Then another very important physical quality attribute, like the color, which is used, it is often used as a measure of maturity, presence of defects or damage of the processing, etc., degree of processing, etc. So, this color sorting, it can be done manually or by using automated system. That is, manually the conveyor belts or sorting tables are there, where the different unsized or uneven colored materials can be picked up manually. But in the automated system, highly accurate photocells which compare the reflectance of the produce, okay, it can eject defective or wrongly colored material, for example blackened one or small fruits, uses by a blast of compressed air, etc. Number of photocells are positioned at different angles, okay, in the system, and which can detect blemishes or large units such as potatoes, red and green tomatoes, and so on. Okay. Here in the picture, one such system you can see the color sorter. Okay. The fruits and vegetables can be quickly sorted automatically using microprocessor controlled color sorting equipment, and the commodity like tomato, apples, oranges, etc. are being sorted using this method in some industry. So, photo detectors, you can see they are provided here, these photo detectors. They measure the reflected source of the produce and compare it with the standard ones. Okay. Then material is being fed here, okay, that you can see that rejected side, that is unmature color, different color materials. So, while they are coming down, there are lamps, the sensor, they sense these colors of the different commodity. The signal is sent to the data processor units, okay, and which finally analyzes and send its output to the ejector. So, of the undesirable or of different color material is rejected. Okay. So, reflected light is processed by a microprocessor which operates a rejection system automatically. So, this is the color sorter. Then roller sorter is another. The produce of sorting generally moves over a belt or a lower roller conveyor. The roller conveyor turns the produces as it moves forward, is preferable to a belt because it allows the sorter to see all sides of each item. Each sorter on the line picks out those products which are not suitable for high marketing. It is sufficient light above the sorting table is also essential for high efficiency of this operation. You can see here in the figure how this roller sorter is used. Then sizing of the fruits or vegetables, sizing is done either by hand or by machine. The machine sizers work on two basic principles, that is, one is the weight and then the diameter. Most effective for spherical commodities like oranges, tomatoes, certain apple cultivars, and elongated commodities like delicious apple and European pears. So, type of the sizing machines may be diverging belt or rope graders, where different speed of the belt makes produce rotate precise. Besides moving forward to a point where produce diameter equals the belt or rope separation. Okay. Cucumbers, pineapples, large root vegetables, etc., can be sized using this system. Then sizing rollers, where increased spaces between the rollers separates longer produce from the smaller ones. It is suitable for the citrus fruits. Okay. Hand held template sizing can be performed manually using a ring of known diameter, or sizing by weight, where weight sensitive trays automatically move fruit into another belt aggregating all units of the same mass. That is, the citrus, apples, pears, or irregular fruits, etc., they can be sized using this system. Then mesh screens can also be used for sizing of the fruits and vegetables. It is generally used for sizing potato, onions, amla, etc. Grading is classification on the basis of the quality. So, there is sorting and grading. The grading main difference here is that grading is the classification on the basis of the quality, whereas the sizing or sorting was a classification on the basis of their physical properties. Okay. So, here this produce is classified into two or more grades on the basis of the surface color, shape, size, weight, soundness, firmness, cleanliness, and maturity to obtain the maximum worth in the market. Fruit grading is an important process that affects the quality, management, and storage of the produce. Grading may be done manually, or there are many mechanical or automated grading system now available. Some basis of the grading and examples are like size and color grading used for citrus fruits such as lemons, tangerine, and oranges. Screen graders are used for pear, lemon, and amla. Grading based on size is used for onions, potato, apple, tomato. Electronic color grading is highly preferable, or highly perishable fruits can be graded using this system. Okay. Grading system may be a static system or dynamic system. Static system is common in tender and or high value commodities. The product is placed on an static inspection table, where sorters remove the units which do not match the requirement for the grade or the quality category. Whereas in the dynamic system, product moves along a belt in front of the sorter, which removes units with defects. Okay. It is much more efficient in terms of volume sorted per unit time. For example, in onion grading, etc., dynamic system has proven to be much effective. Okay. So, the general criteria for the grading of fruits and vegetables may be physical criteria, technological criteria, organoleptic criteria, or commercial criteria, etc. And in all these criteria, like in the commercial criteria, tradition, attractiveness, utility, variety, price, etc., can be used. In the organoleptic, like on the basis of their color, taste, texture, aroma, ripeness, or freshness, etc., they can be graded into different. Similarly, technological criteria, that is whether processing suitability or compatibility to existing equipment, etc. physical criteria under this weight, size and shape etc. are used for grading. Okay. So, here you see that now we will see some of the systems, machines etc. So, screen graders, you can very well see in the picture how it is graded, that is this machine. The produce is conveyed along with a series of belt having holes of different sizes. So, any item is smaller than the hole size of the belt drops down onto a chute or crosswise conveyors below. The machine will have 2 or 3 such belts with the holes of different sizes. The first belt will have smallest hole to remove the smaller size. First, the size of the mesh increases with the subsequent belt, and the largest fraction will be the carry over or from the larger mesh belt. The shape of the hole in the belt is usually square, but hexagonal shapes are also now available. This is usually a harsh method and is not suitable for fruits like apple, peach etc., which require gentle handling. Continuous shaking of the belt provides easy cleaning of the holes and faster movement of the produce. Diverging belt grader, you can see here in the picture, it is shown the grader operates on the basic principle of diverging elements. The produce is conveyed along a narrow channel which the width of which increases gradually as it travels along until it is so wide that the produce drops through the gap by gravity on a belt or chute below. The smaller ones drop through first and the larger ones are carried further. Graders working on this principle are available for different horticultural produces. Then barrel screen graders, see here in the picture, that is the screen there. These graders have cylindrical screens in place on a flat belt screen. As in screen grader, a typical barrel grader will have 3 cylindrical screens. The smallest hole are at the upper end of the sloping barrel and the largest hole are at the lower end of the sloping barrel. The barrel is fitted tilted at around 5 degree so that the produce passes down by gravity. This type of grader is suitable for onion, carrot, beet, etc., gladius bulbs and so on. Roller graders, this is working on the principle of diverging elements, that the produce is conveyed by a series of rollers with a wet grinder and water moves along. The smallest fruits and vegetables drop down first and the larger ones are carried forward. The main drawback of this machine is that it cannot differentiate between a longer and a shorter produce. It is suitable for spherical shaped fruits like oranges, apples, tomato, etc. Link grader, it works almost in the same way as that of the roller grader, but instead of rollers, it carries the produce between the links which moves along the diverging rails. It gives more precise grading than the roller grader. Iris grader, this is a grader where round holes mechanism has been used, and instead of having only 2 links, it has a set of elements arranged in an iris with a central hole. The iris picks up one fruit each at the entry point and of the machine and then moves along a track. The irises widen as they move along, providing increasing diameter of the hole of the fruit. The fruit, while passing through the holes, drops at appropriate place. Mass grader, it is different from the other graders where the produce is graded on the basis of the weight, whereas most fruit and vegetable are brought and sold by both the size and weight. Singulator separates produce into the packet or cup so that each one can be weighed independently. Now, we will discuss new innovation in grading system for fruits, vegetable and spices, and these are the computer vision grader which operate on the basis of tripping buckets that drops to release the pre-weighed item at a particular position. Apples, citrus fruits, etc. are for their grading, these computer vision systems are used. Then video image capture and analysis systems, where it used for size, color and external defect. For example, in the case of coffee bean grading, apple grading, this video image capture analysis system can be done. Then NIR spectrometers, X-ray imaging and computer aided tomography, magnetic resonance imaging, spectroscopy, acoustic methods, or volatile emulsion analysis like E-nose or E-tongue, etc. can be used. These are the novel methods which are now becoming more and more popular. Right. Here, that is some of the this computer vision system, that is it is one of the widely used for quality inspection of spices, etc. It can also be used to inspect the quality of fruits, vegetable or any other commodity. You can see here that there is a image capturing chamber where the sample is of the spices, etc. Sample is through a appropriate handling or conveying system. It is brought into here image capturing system where there is a light source. Okay, the light falls on the product. That there is a light. Some of the light is reflected back, and then reflected light, it goes and it is captured in the device, and which it sends the data to the data acquisition and pre-processing system, which finally the data is processed and it is sent, and there is a control system. So, using this machine, this can give a different grade systems of material. So, at a particular either the color or any other particular quantity can be used by using this computer vision system. Then here the various spectroscopy methods are shown, that is NIR spectroscopy, their working principle, FTIR spectroscopy, Raman spectroscopy or hyperspectral imaging. So, all this, that is in this system there is some light source. So, either absorbance of the light or reflectance of the light, or even some case like in the hyperspectral imaging, there are cameras, hyperspectral cameras, which is there, even X-ray imaging, etc. also, which can be used to detect the some unwanted materials, etc. inside there. So, this image is captured and this is sent to the processing unit, data analysis and processing unit, which finally gives its output and the basis of the particular quality attributes. So, obviously, all these systems are to be first, they have to be trained using that appropriate quality. Like here you see that electronic nose, E-nose system for grading of spices, or it can be used for grading of fruits and vegetables. So, E-nose, that is, there are various sensor in the sensor array, various systems, that is the same thing what is there in our olfactory. Similarly, some metal oxide sensors or other sensors are there. So, the commodity is here, sample chamber, and the air filter or dehumidified air or air pump with that. So, these what are the aromatics, the flavors, etc., that is the volatile components, they are volatilized and they pass through, that is a temperature controller is there. So, the material is heated to desired level. So, the volatile flavors, they come, and these sensors which are there, they sense these volatile products, and again it sends to the data acquisition and pre-processing, and finally analysis and fusion. So, on the basis of that is either PCA or other softwares that you can grade the differences. Like, so obviously with this, suppose you want to find out there is a fresh mango, freshly ripened mango or a spoiled mango. So, obviously that is, it has to be given first, it will take the smell or sense of the what are the fresh mango, fully ripe mango, and then once you give that unripe or even spoiled mango, it will sense it and then take it to its library, and it will compare with that of the spectra which is generated with the pure or fresh mango, and then it will give that segregation on the basis of that. Okay. Similarly, electronic tongue system for grading of spices or for grading of the food, foods or even fruits, etc., that can be done. So, here electronic tongue basically it works. That in the electronic nose, that is the like those which we have the olfactory system. In the electronic tongue, like in our taste buds are there on the tongue, so similar system, that is whatever function is done by our tongue, the same function here also. There are certain sensors with specific properties, okay. And then the commodity heat tongue with the voltammetric chemosensor is used to discriminate between pure commodity or there is adulterated, like here this system is shown that pure cardamom and the adulterated cardamom. So, obviously, the pure cardamom first is taken, extraction and its separation, and then this extract is sent to the sensors. The sensor is taste, that is like those are the taste buds out there. So, similarly, it senses those elements here, and then data is analyzed and it is kept into its memory. Then when you give the adulterated one, okay, again it is a extract, then it will analyze the adulterated one, these chemicals etc., which are present there, and then it will compare with the library and then discriminate the system. Okay. So, the mechanism in the taste recognition by e-tongue occurs in 3 levels, you can say, that is receptor level, that is chemosensitive metal oxide sensors, transmission level, the detectors and transducers are used for that, and then the perception level where data analytics and chemometrics are used. Okay. So, automation of fruits and vegetable grading system, very important. Now, it is becoming more and more important, and industries are coming forward to use it, because it is many grading facilities and guarantees the safety and security of the produce. It is less labor intensive, okay, labor intensive work of hand sorting, traditionally considered the only, because accurate methods for fruit grading is completely eliminated by having a fully automated conveyance system that ensures that the fruits are fed into the sensors at a constant level. So, this is why it is becoming more and more popular nowadays. They can measure color, size, shape, even external defect, sugar content, acidity and other internal qualities that as I told you. So, the automation, the role of automated grading system may be like efficient, to get the efficient, strong and labor saving. It may be to get a uniform fruit quality or enhancing market value of the produce, fair payment to producers based on not only on the quantity, but also on the quantity of the product, farming guidance from grading results of GIS etc., and contribution to the traceability system for food safety and security. So, automated grading system are very important. Here you see that is just one schematic is shown, automated tomato quality grading using clustering based support vector machine. Okay. So, the input test and training images etc. So, there are again various systems, computer vision system etc. So, when you give the different products, they will record the particular quality or particular parameters, and then it will given there like RGB to gray scale conversion, histogram and threshold calculation, gray to binary conversion etc. It will process whatever system you want them. Then it will go, that is the image training, SEM training or image testing. So, that is training is testing is done, and finally, it gives different categories than first grade, second category or third choice grade etc. You can see here the data set tomato samples representing the first, second and third grade tomatoes. So, first grade it may be different, particularly even pure green or fully ripe or medium ripe. So, that may come in a pure grade, but second grade and third grade, that is the green. In the green category you can see second grade or third grade. So, this all the things, so automated systems can detect these things. Similarly, the orange grading system here also, that is the automated orange grading system. It has been shown how it work. At the first stage of the mechanization, plates with holes of orange fruit sizes are used for sorting. Then machine vision and near infrared system have been utilized and improved with engineering design to convey fruits to detect fruit size, shape, color, sugar content and acidity etc. The system inspects fruits with color CCD cameras installed at 6 different locations. You can see here, okay, and in line to provide all side fruit images with lighting devices. The light devices are made by halogen lamps or LEDs fitted with the polarizing filters to eliminate halation on glossy fruit surface. The near infrared inspection system consists of halogen lamps and a spectrophotometer to analyze absorption bands of transmissive light from fruits. X-ray imaging system is sometimes installed on each line to find internal defects such as rind popping etc. So, these are the system which can be used. Now, here the robotic grading system is again coming in a big way. In the figure I have shown you how one robotic system is used, okay, to grading robot for deciduous fruits such as peaches, pears and apples to automatically provide fruits from containers and to inspect all sides of the fruit. So, this robot system here in this figure which we have shown, it consists of two 3DOF manipulators in which one is providing robot while the other is a grading robot, and the grading robot it has 12 machine vision system. Okay. The after container comes under the providing robot, you can see here in figure that is 1, then 12 fruit are sucked up by the suction pads at a time, that is 2, and are transported to intermediate stage marking space toward vertical direction on the page between the fruit, that you can see here in the 3. This then the grading robot picks 12 fruits up again, that is the fourth year it will pick here 12 fruits again, and 12 bottom images of the fruits are acquired during the manipulator moving to trays on a conveyor line, which is shown here by 5. Okay, here. Then just before releasing the fruit to the trays, that is 7, 4 side images of each fruits are acquired by rotating the suction parts. The fruits are pushed now onto a line, that is you can see here 8, here the fruits are pushed into, and the top images are acquired by another color camera stationed on each line. Okay. And the fruit color, size, shape and defects are therefore measured. So, this is the robotic, how the robotic grading system works. Okay. Now, I will summarize this lecture saying that the first sorting and grading are an important process that affects the quality, management and storage of the products. Manual grading is expensive, laborious and efficient, and therefore, automated grading system should be used. The most important difference of the automation system from the conventional machines is to be able to handle a lot of precise information. These automated system to handle the comprehensive data on agricultural products and foods, understanding of the diversity and complexity of biomaterial properties is required, and sensors to collect the data should be often designed based on these properties, that is color sensors, texture sensors, smell sensors, taste sensors etc. Okay. And then machine vision technologies are utilized and improved with engineering design to convey fruits, to detect fruit size, shape, color, sugar content and acidity etc. With this, these are the references used in this lecture. Thank you very much for your patience hearing. Thank you.